Oh, I'm a tech woman right down to my toes. I started my career as a systems engineer, and systems engineers are taught to look at the bigger scope and then drill down. So I tend to look at most aspects in life that way, and I'm a technology buff. I love it. I absolutely love it. I am fortunate enough to be in an industry that's evolving. So the industry is business intelligence, and that can sound really boring, but what it is it's giving mid-sized companies tools to make fact-based kinds of decisions that they never had before. So enterprise companies could afford this, and now because of the cloud, mid-sized companies can. So I am definitely shaping the future because I'm giving these companies the ability to do things that help shape their industries. I get up in the morning because every day I have something new and exciting to do. I also often don't know what that new and exciting thing is going to be. So it's the whole idea of discovery and of being able to do something new.
When the first PC came out, the MIS manager at the time said, let's give it to one of the girls because they'll never amount to much. And I volunteered. And that actually changed my career. And it got me out of programming all day long. So it was a good move. And as the years went on, every conference, every training I'd go to, I was surrounded by men. And I always thought it would be really good to have more women in the field. So anytime there was an opportunity to hire a woman, I would, as long as they were qualified. I think women have a lot of skills that are good for IT, and I think not enough women go into it. Sometimes the really skilled technical people have a hard time communicating in a way that people understand. So I think women bring something new to the table where they can explain things in a way that everyone will understand and have a little bit more patience when it comes to showing people how the technology works.
I love to build and design things, and with civil engineering, we wouldn't have a society today without civil engineering. That's the basis of our world. And the neat thing about civil engineering is that no matter what project you're working on, it is never, ever the same thing. I have worked out in civil engineering, out in industry, and when we were trying to hire another person to work with me, we had a hard time finding any qualified people to fill the position. And at that point, I knew that I need to go do something for that and try and teach some of these younger generations on how things are built and spark their interest and make them qualified people. There really is not a lot of women in civil engineering. There should be, because we're so detail-oriented at times, but that is a big challenge, is that women stepping into the civil engineering world, which has always been traditionally a man's world.
Analytics is still something new. When I say that I'm the CAO, they're like, what? CIO works with information. Analytics is information. I'm grabbing data, which is a lot of information, and turn it into understandable portions. I visualize data, I extract data from the big mass. For my word, that means that we're going to grab a bunch of high school students, and based on the portfolios that they put on the website, we're going to go ahead and try and find some patterns. Right now, that doesn't really exist. No one is trying to find patterns. No one is trying to find correlations. Not to mention that, what about personal traits? What about the best engineers all love Twinkies? Not anymore. Maybe there is a correlation like that. Maybe it is worth pointing that out. I explore new ways. I ask the question, what if? I just imagine, what if we had a much better understanding of high school students? What if we had a much better understanding of motivation? I just asked a bunch of what if questions, and then I'm trying to find a solution for those what if questions.
Novatech helps people learn how to use medical devices. We create the documentation, all of the instructions and the manuals, as well as the training and e-learning programs that teach technicians, end users, laboratory specialists how to use the devices. When I get up in the morning every day, I look at, what new challenges are there ahead of me today? What can I do my best at? How can I learn? How can I grow? What is one new thing that we can do today? And so owning a business where you have that opportunity every day is very exciting. And growing up, my mother left Kodak to start her own business. So I always had a role model in my mother. I didn't know any different. When I had the opportunity, I bought the business. So I personally have never had the experience of the glass ceiling because I had the role model who showed me that I could do whatever I set out to do. I think it's my duty to be that role model for others as well.
Responsible for our call accounting and our telecommunication expense management customers and their satisfaction with our products, technical support, and we also do wireless help desk support for our CHEM customers. As a leader in technology, it's important for me to have a vision, for me to have a full understanding of the technology spectrum, but also with the people that I work with to help them see that vision, to learn how to establish a vision for themselves, and also learn the key fundamentals of what it is to be a high-powered knowledge worker. I'm incredibly detail-oriented, almost to the point where I could be obsessive about it. And it's almost fun to be obsessive, but you have to know when to stop and when to pull yourself back, because there'll always be something else.
On an average day, I'm working with teams that are designing products, looking at market trends, trying to solve customer issues out there in the world of healthcare. One of the interesting revelations I tell people is that when I came out of college, I thought I knew it all. And then I quickly realized, in my 20s and 30s, I pretty much didn't know anything. And so I still to this day feel like there's so much every day when I walk in that I can still learn. And so I think that curiosity along with the passion really helps me be successful. I'm shaping the future by leading teams that are really trying to look at what should healthcare look like in the future. How can we actually help to accomplish things in terms of improving patient care? So we work with doctors, radiologists, physicians, and we try to look at how can we reduce errors, how can we improve outcomes, how can we get them the images faster, how can we get them better images. Those are things that we're doing to really shape the future. We try to cut off minutes that radiologists need to be able to read reports. How do we get the ICU doctors information 5 minutes quicker? How can we get them a good image in the operating room so that they can actually finish the surgery 10 minutes faster? Those things, I think, will shape the aspects of healthcare and what you want as actually a patient from a care perspective in the future.
I teach microelectronic engineering. This particular discipline deals with how electronic devices can be made at very, very tiny scales. So basically, we are building those transistors that go inside your computers and cell phones and electronic instruments. So this technology is really groundbreaking because we are making things which are so small, of the scale of nanometers. And to teach that to students, what it involves in the design, fabrication, and actually testing of these devices and how they are realized in the laboratory. That's what I teach. The main frontier is how to make these devices as small as possible and then how to connect them in high density. So I look at in which way we can achieve. For example, in today's transistor technology is around 22 nanometer in production. To go to 14 nanometers and 10 nanometers, such small sizes, we need new materials, we need new designs. So that's what motivates me. So could we change another material on this semiconductor chip? Could we make a new design so that we can achieve these breakthroughs? Science and engineering is a very fascinating field. So I would want other women also to experience that passion that I experience.
My job is two parts. One is recruiting the best and brightest entrepreneurs, both from new ventures as well as growth stage firms, which are established companies here in the upstate region that are looking to retool their sales and marketing strategy and get to that next level of growth and revenue generation. The second part is really working with our excellent instructors and our volunteers that work hands-on with our entrepreneurs so that it's not just an experience of sitting in classroom boot camp training. It's really getting that coaching and mentoring that you need to develop an effective business plan, go-to-market strategy, and a key piece is understanding where and how to get the funding you need to execute your plan. One of the biggest challenges that many of our entrepreneurs have, whether they're scientists or engineers, is they have the greatest idea, the greatest intellectual property, but when they have to talk to potential funders and put it in layman's terms, that's where they tend to struggle. My role is really helping them communicate effectively what is the business result they're trying to drive with their technology so that we can have better products, better services come into the market. I think a tech woman is someone that uses technology to get the job done.
Our group focuses on developing optical technologies for high-powered laser systems. So essentially, we're trying to design or develop materials that are going to build a laser so that other scientists can come in and hopefully someday develop another energy source, which is basically trying to recreate what the sun does in the lab. It's probably not as sci-fi as you picture. The laser is about the size of a football field. What you end up seeing is a lot of hardware, a lot of tubes. Underneath all of that are some optical components, and they really are what drive the laser. They are what point the laser to where it needs to go on the system, and there's a lot of different diagnostics around the laser system. It's fun to be a part of trying to build this laser system and develop an alternative clean energy source, maybe someday in the future for our kids, maybe 50 years from now, whatever it is. But I think we will get there, and it's cool to be a part of that.